We've installed the valves and we've seen how those control the flow of gases in and out of the combustion chamber. The next thing that we would normally do is install the cylinder head onto the engine block. But what we're going to do instead, we're going to skip that and just delay that slightly while we talk about the camshafts. This is a camshaft, and this is the piece that controls the valves. It opens and closes the valves. And this is an incredibly precisely machined part, probably the most precisely machined part in the entire car. So a cam is similar to a crank, except a crank generally converts linear movement, for example the pistons, which move up and down. The crank turns that up and down movement into rotation, and the camshaft does the opposite. The camshaft turns the rotation of the shaft into up and down movement of the valve. So we've already seen that to open the valve, we simply push down and that pops open, being a pop-it valve. Each cam operates just one valve, and the valve is held in contact with the cam surface here by the spring. So the spring pushes the valve up, holds the valve closed. That sits there against there, and as we rotate the camshaft, that forces the valve open. And then once we've gone past this point, the valve is then pushed closed again, or forced closed by its spring. Again, I think we need diagrams for this, so we'll get them made. In the meantime, we'll just do it this way. There's various different arrangements of camshafts in engines, but we're lucky because this engine has a very simple arrangement. We have two camshafts. This is the exhaust camshaft. This is the intake camshaft. And the exhaust camshaft opens the exhaust valves, and the intake camshaft opens the intake valves. And we can see we have 8 cams on each camshaft. That's because we have 8 intake valves, 8 exhaust valves, 2 of each in each cylinder. In this engine, the camshafts sit above the valves. So if we take the head, the camshafts sit directly above the valves and act on the valves to open and close them. There's other types of arrangements of camshafts in engines. This is what's known as a dual overhead cam engine because we have 2 camshafts. If I can get this one in, let's get it the right way around. We have 2 camshafts, so it's a dual camshaft, and they're overhead, so it's a dual overhead cam engine, DOHC. We'll talk about this type of engine first, and then we'll come back and discuss some of the other arrangements of camshafts that you might come across. If the camshaft acted straight onto the valve stem here, we've got a thin stem, and as the camshaft turns and pushes down on this, we not only have the up and down force, which is what we want this valve to move up and down neatly in its guide. We don't want any side-to-side movement, we don't want lateral movement, and no matter how smoothly the camshaft runs, you will find that there'll always be some side-to-side movement. As this rotates, we have this force diagonally, which is going to want to twist the valve in its guide. So instead of acting directly onto the valve, we use what's called a follower, a lifter, or a tappet. It's all the same thing, 3 words which are equally commonly used around the world. A follower, a lifter, or a tappet to absorb that side-to-side movement, cancel it out, and act like a buffer. The follower has a flat top, a nice smooth flat top, and that means that we've got a nice smooth big surface for the cam to act against, much bigger than the valve stem itself. So the follower fits into a bore in the cylinder head. So we've got a nice circular bore here, and the follower fits smoothly into there. Inside this bore is an oil hole, and the bore itself is separated from the follower with a film of oil. So this flows nice and smoothly, and once this follower is in its bore, it can only move up and down. There's no side-to-side movement whatsoever, and that means that this follower, which pushes down on the valve, just pushes the valve very cleanly open and close with no side-to-side movement whatsoever. Now, I thought that tappets, followers, lifters, the tappet word sounds complicated. It sounds like some complex piece of engineering. I've got this stuck in there now. I need to find a magnet. But it's really not complicated at all. It's a very, very simple concept. When the valves open, it should be fully open. And when the valve is closed, it should be completely closed. There should be a seal around it. We want to be sure that when the valve is closed, it's seated perfectly in the valve seat and we have a gas-tight seal. Because if the valve doesn't close completely when it should be closed, then we have gases leaking to and from the combustion chamber, poor compression, and the engine gods will come and strike us down with poor performance. We want this valve to be in contact in two places. We want the seat of the valve, we want the face of the valve to be in contact with its seat down here. We also would like the top of the valve stem to be held in contact with the cam. So the valve spring's job is to pull the valve up and hold it against those two places. But to ensure that those two places are in contact at all times is an almost impossible engineering task. In fact, it is an impossible engineering task because the valve goes from -5 degrees if we're sitting in the cold somewhere all the way up to hundreds of degrees, and that causes some expansion. So if we were to get those 2 points in contact at the same time when the engine was cold, when it's hot, we've got problems. Likewise, if we set them when it's hot, when it's cold, we also have problems. Not to mention the wear and the precision of engineering required. So instead of doing that, what we do is we prioritize the valve being closed. That is a gas-tight seal. And we keep a very small gap, a clearance, between the top of the valve and the camshaft. So there's a gap. And in our case, we have the follower or the lifter sitting on top of the valve stem here. So we'll have a gap. It's just some slack inside this, a small gap between the follower and the camshaft, only when it's closed. So on what we have here is a base circle. This is a perfectly circular cam up until it begins to push out and open the valve. So this is called the base circle, and we want the clearance to exist when the valve is closed, and we're on our base circle here. We have a very, very small gap, thousandth of an inch, between the valve, between the follower in our case, and the cam itself. So that small gap between the valve and the camshaft is known as the valve clearance, or the lash is another name for it. There's a lot of different names for these things, and I think it's because this technology is very old. This goes way back to the steam engines, and those obviously developed all around the world. So maybe different places in the world developed names hundreds of years ago for these things, and they've just stuck and become so common that we don't have a general name that everybody in the world uses. So valve clearance, valve lash is what we've got there. And that is specified by the manufacturer. It's a very precise measurement. We don't want too much of a gap. We don't want too much valve clearance, because too much and we end up with slop in the movement. We end up with parts banging together very, very quickly, because this is turning 15 times a second or so. And that's going to cause excessive noise in the valve train, and it's also going to cause wear. You can hear excessive valve lash or excessive valve clearance. You can hear it in an engine, particularly when an engine starts. You can hear this. That's the sound of that clearance inside there. And as the engine warms up and the parts expand, you very quickly hear that noise stop. That's a sign that you have too much valve clearance, basically. If we have too little valve clearance, then as the parts expand, say this valve expands ever so slightly in length, and when it's in contact with the base circle here, it may no longer seat properly at the bottom. So we end up then with a poor seal, poor compression in the engine. So valve clearance, essentially it's a way to ensure that the valve is closed completely by leaving a very small gap between that and the camshaft, and ensures that the camshaft is never going to hold the valve open. Let's take a closer look at this follower or lifter or tappet. So the lifter in this engine is what's known as a solid lifter. It's just made of a piece of metal, or two pieces of metal in this case. This design is known as a shim in bucket type. What we have here is what's called the bucket. I'm not sure which side is the bucket, but let's say this side. This small part here is in contact with the valve stem, and this part is what meets up against the camshaft. And in the top here, we have a space where we fit this shim. And the shims are sold in different thicknesses, and using a different thickness of shim is how you can adjust the valve clearance. So if there was too much valve clearance in this particular lifter, we would add a thicker shim on the top to move the top up slightly and create a smaller clearance between the top and the camshaft. So a solid lifter is the most simple lifter that you can get. Its advantage is in its simplicity, very easy to manufacture, and there's nothing to go wrong with it. Its disadvantage is that as the engine wears, it becomes necessary to check the valve clearances and to maybe use different shims to adjust those clearances. And that, with older engines, was something that needed doing at fairly regular intervals, every few tens of thousands of miles or so. But as engine oils have improved, quality of materials has improved, it's now much less likely that clearances need to be adjusted. However, there's another type of lifter, which is what's known as a hydraulic lifter, or a hydraulic follower, a hydraulic tappet, or a hydraulic lash adjuster. You can find it called all of those things, but essentially what happens is we have inside that is a reservoir of oil which is filled up, pumped full of oil by the engine, and as the essentially it acts like almost like a bouncy castle. It acts to fill up that area with oil and take up the clearance, and that sets the clearance more precisely. So a hydraulic tappet or hydraulic lifter doesn't need maintenance, or it shouldn't need maintenance. Of course, there's disadvantages too, which is that those hydraulic lash adjusters can gunk up with oil and contaminants. They might not work as perfectly as they should do, and you end up with excessive noise. So, for example, in this Miata, initially the engine started with solid lifters, then the subsequent version had hydraulic lifters, which were not very popular, caused valve noise, they weren't great, and they were then replaced with solid lifters again. I'm not sure what happened after that. I suspect it's gone back to hydraulic lifters, but who knows? Anyway, there's just two different types of lifters that you should be aware of. Solid lifters like this, and this is a common modification. If you have an engine with hydraulic lifters, you may swap them out for solid lifters if you're looking for performance or other alterations. Solid lifters are fine. In the racing world, solid lifters are good because the engine's being dismantled on a regular basis. It's no problem to put hours into the workshop to service that engine, to measure the clearances, to adjust those clearances. All those things are fine. For a consumer vehicle, people want as little maintenance as possible. And so that's why hydraulic lifters are more prevalent in those engines, because we want it sealed for life. We want as little maintenance as possible.